Under 7.5 on page 142, we are going to learn how to apply and interpret the regression equation. And under that, there are some 4 bolded statements, and we need to understand them before we can attempt example 6. 1. A regression line can be used to estimate the value of the dependent variable for any value of the independent variable. Remember, the dependent variable is the y, is always on the y-axis. The independent is always on the x-axis. Point number 2, interpolation is when you estimate the value of a dependent variable within the range of the data. Extrapolation is when you estimate a value outside the range of the data. Values estimated by extrapolation can be unrealistic. I'll explain that in example 6. Point number 4, you should not, in general, extrapolate, and you must view any extrapolated values with caution. And I want us, with that in mind, we attempt example 6 on page 142. And we are told that the results from an experiment in which different masses were placed on a spring and the resulting length of the spring measured are shown below. Now, the table shows when a mass of 20 kgs is placed on a spring, then the length of 48 centimeters is registered. When a mass of 40 kg is placed, then the length of 55.1 centimeters is registered. And I want us to just answer the question. The regression line for the data was found to be y is equals to 43.89 plus 0.2305x. That is the regression line. Find A, the value of y when the mass of 35 kg is placed. The value of y when a mass, part A, Roman 1, y when the mass of x is 35, we just need to substitute x in the equation of regression. Y is equals to 43.89 plus 0.2305x, which is in this case 35 kg. And you realize that our value of y is going to be 51.96 centimeters. You can confirm that. A, Roman 2, we are expected to find the value of y when the mass of 120 kg is placed on the spring. Now, at the same time, we just need to do exactly what we did in part A. So our new value of y is going to be 43.89 plus 0.2305, now the mass of 120. And you'll find now our new value of y is going to be 71.55 centimeters. That is our new value of y. But listen to part B of the question. It's asking us, explain what the two constant 43.89 and 0.2305 mean in this context. If you look at the equation of regression of y on x, we have two constants, 43.89 and 0.2305. Of course, this one resembles the equation of a straight line, whereby 43.89 is the y-intercept. That means 43.89 is the length of the spring when we have zero mass placed on it, because this one is actually the y-intercept. If you were to sketch a graph that looks like this, then this particular point, call it point A, the coordinate of that should be 0, 43, 0.89. So this is the y-intercept, explaining the length of the spring when no mass is placed. What about 0.2305? This is the rate at which y increases for every kg increase in x. It's called the gradient. 0.2305 is the rate at which y increases with each and every kg of x. It is the gradient, and that is exactly which is explained like. So if you're talking about this one could be 0.23055, and this could be 1, which is now when this is 1, generally it's trying to capture the gradient of that line of regression. But I want to say something about the value of y when we have mass equals to 120 kg, and say this: the value 120 kg is not anywhere given in the original table. So even the value we are going to realize of y, which is 71.55, this is going to be an extrapolated value, because 120 kg is of course outside the range. It's supposed to be here. We have not been given, and therefore we don't know the value of y. It is outside the original range. So the value of y, which is 71.55, is already an extrapolated value. It is a value that should not be relied on so much, because we don't exactly know how the spring would behave beyond 100 kgs. But of course, it is a value that we have realized through calculation, but it should be looked at, or it should be used with a lot of caution. It is extrapolated because in the first place 120 was outside the range. All right.